Hi guys, welcome back to Calculator Bootcamp. This is day 3. The name's a bit of a misnomer. We're actually doing this across, I'm giving you guys 2 class periods to work on this because I think it's kind of an involved skill. So today we're going to be working on correlation and transformation. Correlation is something you guys already know how to do from chapter 3. Transformation was something we weren't actually going to cover until chapter 12, but I want to work it in today for 2 reasons. First of all, it is fair game for the AP test because of the way the new unit guides work, which we didn't completely follow, but I think it's pretty simple. You guys will catch on. It's a very basic calculator skill. And the other reason is we actually need transformation to understand today's work with today's data set, which is on the coronavirus cases in 2 different countries. So let's get into this. I want you guys what we're actually going to do is work through the US cases together, the Italian cases together, and then I want you guys to work on the US cases on your own. So you're going to have to go through this process twice. The video will walk you through one of them, and then you'll have to do the other one by yourself. If you have any questions about any of this stuff, please make sure that you're looking on my website. I sent an email about this, but I have office hours regularly scheduled through Zoom. So you can feel free to drop into those, the ones that are for stats, and I'll be happy to answer any of your questions about the review assignments or the exam or anything else to do with stats. Okay guys, so today we're going to look at graphing a correlation on the calculator, and we're going to use both the TI-84 and the TI-nspire. And today we're actually also going to include another skill that we didn't get to cover in the course so far. So this is data transformation. So real quick, 5-second summary. Data transformation is taking a data set, applying some kind of function to it to change the values of that data set so that we can use our tools for linear correlation. And I'm going to show you guys why this is so important in just a second. So if we open up the data sets, I actually have some data here from the COVID-19 pandemic. And these are the data points from the US and Italy case numbers across a chunk of the days that the virus was spreading through both countries. So what we're going to do is actually use this data today and graph a model and try to fit a linear model to the curve. But the problem, a linear model to the data. The problem is if you look at this data set, it is very clearly nonlinear. Now, back in chapter 3, we would have said, okay, it's not linear, tough, can't do it. In chapter 12, which we didn't get to, we're planning on learning some tools to actually transform this data, and I'm going to teach you one of them now. So let's look at this on the 84. And what I'm going to do is I'm actually going to work through this whole process on the 84, and then I'm going to work through the whole process on the nspire. So if you have the nspire, you can probably skip to about halfway through the video. If you have 84, you can just watch the first half. So what we're going to do is we're going to take these data points. We're only going to go up to about the 20th data point here, but we're going to actually graph these. So I'm going to bring up my 84. And what we're going to do, let me quit out of this so I can show you how I got here. You're going to press the stat button, and then you're going to press edit. And this is going to bring you to the list editor. In your first column, you just want this to be a number of days. This is going to be L1. So you just want it to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that was 2. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, no problem there. So now in L2, we're actually going to start putting in case numbers. So for the Italian sample, this is the green dots, the Y1 over on my Desmos chart. So we're going to start at 230, then 232, 374, 470, 653, 889, 1128, 1713, 2048, 2804, 1713. I'm actually going to speed this up a little bit for you guys. Okay, and now we have that data set entered there. So these are all the first 20 data points. I went right down to this 17,660 down here. And we're not doing the US data set yet. That'll be in purple, and we'll get to that in a minute. So what I want to do is just look at this data, okay? And the way we're gonna do that is a scatter plot. So what we need to do is go to stat plot on the 84, which you can do by going to second, y equals. We're going to go down to plot, let's do plot 2, just because we'll have the points be read. Turn this on. Type you want to be the first type. Your X list is going to be L1, your Y list is going to be L2, and let's just make the marks the larger dot here. Now what you can do is go to zoom, and you're going to go down to zoom 9, which is zoom stat. Okay? And at this point, you should be able to see the data set. So, if you have not noticed the problem with this, the problem is that it's non-linear. Okay? So this is a non-linear relationship. You can't just slap a line on this and say, okay, great, line of best fit, right? That's not how our tools work. So what we're going to have to do is do something called transforming the data. Okay, so if I go back into stat, and I go back into edit, here's what I'm going to try. Now, in chapter 12, if we had done the full version of this, I would have probably taught you that there's a couple different methods you can use here, like a 1 over y, or a log transform, or an ln. And the one we're actually going to use here is an ln, okay? So what we're going to do is go up to L3, and we're going to transform it like this. We're going to say that L3 is the ln, the natural log, and now I need to put in L2. So I'm going to go to second and stat, which is going to bring me to my list menu, and I want to do L2. And what this is going to do is automatically set all the values in this column to the natural log of the L2 numbers. Okay. Now what you're going to notice is that these numbers are a lot smaller, and they change by a lot less because we've now taken a logarithm of all those values, which should take an exponential relationship and make it linear. So what we're going to do is pop back over to our stat plot. So second stat plot. We're going to go back down to number 2, where our plot is. We're going to keep it on, but now we're going to switch this Y list to be L3. So we're going to go into our list, variables, we're going to select L3. Okay, now we're graphing L1 on the X and L3 on the Y. Again, we probably want to zoom this to stat because we changed the values. And now, lo and behold, it actually looks linear. Pretty cool. So what we're going to do here, we want to finish our analysis by fitting a trend line to the data so that we can see what it actually looks like. And to do that, what we need to do is go into stat. We're going to go into calc. And we're going to go down to a linear regression. We'll do AX plus B with X1 or L1 as our X list, and we need this to be L3, so we're going to go second list down to L3. Our frequency list, we don't need to put something there. We do want to store the reg EQ, that's the regression equation. So let's go into our vars, because we're going to set this equal to y1. We're going to go over to the yvars function y1. So that way it's actually going to store our line in our y equals window, and we'll calculate that. Okay, so here's our linear regression. What you can do at this point, if you were working through this on the calculator with paper handy, you could write down these values. Notice that our intercept is 5.33, and our A value is 0.235. And after that, we can actually go to the y equals, and we see that that same line is stored right there. We have 0.235x plus 5.3. If we now go to graph, it's actually going to show us our data set, which has been transformed with the line of best fit right through. Now, if you really wanted to be thorough with this, you'd go in, you'd check the residuals, you'd see if there's a pattern. It does actually look like we might have missed a bit of a pattern. I'm not sure if you guys can notice this, but the points on the left side and the right side are slightly below the line, whereas the points in the middle are slightly above the line. That could potentially indicate an issue with this model. But we're not going to worry about that for right now. We've got our graph, we've got our equation, and those are what I actually want to see from you guys. Now, that gets you through the Italian data set. I do want you to repeat this process with the US data set. I've given you guys 2 class periods to work on this, so you should have more than enough time to generate both of those scatter plots and the trend lines and include that in the worksheet I sent. Okay, so now that we've worked through that process on the 84, I want to show you guys how to do the same exact process on the Inspire. Here I am using the CAS app. If you're using the iPad CAS app, this should be basically the same. If you're using the iPad calculator, you should have pretty much the same tools here. And by the way, not having the CAS will not affect any of the instructions I give through this video. So if you have one of the non-CAS calculators, I think you can do all the exact same steps and it will work exactly the same. Okay, so the first thing we're going to do is go to menu and we're going to open up, let's see, a lists and spreadsheet. Okay. Now, because this is the Inspire, we can name our columns, which does make our work here a little easier. I'm going to call the first column days and the second Italy. Okay. And what we're going to do is for the first column, we're just going to put in the number of days. So for example, 1, 2, 3, we really just want this to go through 20. Okay, there we go. And now we're going to put in the Italian case numbers for each of those days. So on day 1, and by the way, these days are slightly normalized to make the comparison between the two countries a little easier. But on what we're calling day 1, Italy had 230 cases. On day 2, it had 232, and so on and so forth. I'm going to put these in to fast track us a little bit. Okay, put in all that data. So now we have days 1 through 20 entered, and we have Italian case numbers for each of those days. So what we're going to do next is actually add a new page. So we'll go Control, Doc, and we'll add a data and statistics page. Now, we were smart. We named our variables. So we're going to put days on the X and Italy on the Y. And right now we're seeing the same problem that we saw when we did this on the 84. That's not a line. So this is not a linear relationship. Therefore, we can't use our normal linear regression tools to model that relationship. So what we've got to do is what's called a transformation. Okay? And how we're going to do this on the Inspire is actually really easy. It's pretty easy on the 84 too, but I think it's even easier on the Inspire. So what we're going to do is make a new column. We'll call it ln of Italy. And you can't do that. We'll call this natlog Italy. You can't do that either. Natlog Italy, all one word. So what we're going to do is instead of putting in individual data points, we're going to set this column equal to ln of Italy. And what this is going to do is take each row and take the natural log of the Italian value, the Italy value, so the raw case numbers, and it's going to just find the natural log of that and automatically populate the column C. So let's see what this looks like. Awesome. So it gives us, it's not actually rounding those values because I have my calculator on exact. Basically, it's just taking the natural log of each of those values. So what we can do now is go over to 1.2, which was our graph doc. And we're going to change this from Italy to natlog Italy. And lo and behold, that pretty much straightens it out. So what we can do now is go to our menu, and we're going to go to Analyze. We can pop in a regression, and we're going to use our A plus BX model here. And what that does is it actually gives us our regression. Okay, so here we have 5.3147 plus 0.235761 times x. Now, this does not mean, and I want to be clear about this, this does not mean that the cases are increasing by 0.235 per day, which you might think that this does. That's not true. Because we've put it through the natural log, you actually have to raise some things to the, you have to raise e to certain powers to get the actual number of case numbers back out. But what this does let us do is actually put a numerical value on the slope between these two variables. And it, of course, lets us do all our normal regression tools. For example, we can look at the residuals here and actually look at the residual plot. And if we wanted to, oh, that's not a great residual plot, so there might be more lurking here. But if we wanted to, we could go back into this and, how do I have the residuals? We could look at things like the R value and so forth. We're not going to do that for right now. What I wanted to see was that you guys could enter this data and generate this graph and plot the trend line through. So what I am going to ask you to do is submit a really just this picture. You can screenshot it on your iPad if you want and just attach it to that worksheet. So pop it right in there, and that'll be your submission for the Italian case. And then what I want you to do is actually go in and grab the US numbers for days 1 through 20 and repeat that process and see what you notice about the two samples, whether there's any differences, and what you think kind of explains all those different things. You don't have to write any of that up, but I encourage you to think about it, especially with all the news sources on this going around. It's interesting to kind of think about why the relationships in different countries are different. A lot of different theories out there. But a good thing to contemplate, I think, as we're all trying to make some sense of this. So I'm going to leave you guys with that for now. Remember, you have 2 days to work on this, 2 full class periods, and of course you have actually all of spring break to finish it up. So you're going to have like a couple weeks here. Please make sure that you're doing some nice work on this. Don't leave it till the last minute. I don't recommend that. Knock it off before break so you don't have to worry about it over break. As this is one of my last videos going up, I want to wish you all a happy spring break. Please take some time, if you can, as much as you can, to relax. And I know, obviously, we're not all going to be spending time with friends, hopefully family, but please try to take some of that time to relax and slow down and just enjoy time together in any way you can.